Alright class, today we're talking about squares and square roots, and this is important in terms of being able to estimate and do things mentally with our brains, and also it will be something that we use throughout Math 8 to calculate various things, including Pythagorean theorem later on this year. Alright, our learning intentions are that you can define a perfect square, you can identify the perfect squares from 0 to 400, and you can identify two consecutive perfect square whole numbers between which a square root of a number lies, between 0 and 400 lies. This means that we're going to be able to estimate a square root by knowing what two perfect squares are on both sides of that square root that we're looking for. And our SOL is given here, it's 8.5. Alright, what are square roots? Well, square root is an operator that we apply to a number, and it can give us a rational or irrational answer. The symbol itself is called the radical symbol. The letter on the inside of the radical symbol is called the radicand. We show it as an A here, but this could be any number. The radicand is the number inside. And we're under flap 1 of your foldable. Now, why do we call it a square root? Well, it's because when we take apart, so to speak, a square root of a number, it gives us two numbers that we multiply together to get the radicand that we started with. So let's look at one. The square root of 25, for example, is 5, because 5 times 5 is equal to 25. Okay, think about a square. The area of a square is the side times the side, or the side squared if you look on the formula sheet. Alright, well, if we have a square of side 5 and another square of side 5, then we know the area of that square is the two sides multiplied together, 5 times 5, which is 25 square units. Okay, so I want you to think about the fact that these squares give us these are why we call these perfect squares. They make perfect squares when we draw them out like this. Alright? Now, one of our learning objectives is to know the squares from 1 to 400. So that means our square roots go from 1 to 20. So let's go through them real quick. Pause the video to catch up here. Pause the video to catch up here. So we start with the square root of 1, or the square of 1, that's 1. 2 squared is 2. 2 times 2, 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Now you should know all these. Been in math long enough, you should know those squares. 11 to 20 can get a little harder. 11 is 121, 12 is 144, 13 is 169, 14 is 196, just flip the 2. 15, 225, 16, 256, 17 is 289, 18 is 324, 19 is my hard one, that's 361, and 20 is 400. Alright. Now let's use this knowledge to help us on these examples. Okay? The first one, the square root of 144, pretty easy. Go into the table. We know that the square root of 144 is just 12. Okay. 81, same thing. We know that one pretty easy. The square root of 81 is 9. Now, when you have an operator like this, that means we're going to take the opposite of the square root of 25, the negative of the square root of 25. So that means the negative of square root of 25 is negative 5. Now, in example 2, it talks about getting estimates to the nearest hundredth. But let's talk about what two numbers this falls between, and we'll do some more of this in class. The square root of 98. Okay, you have to think about what square is below it and what square is above it. The square below it on the number line would be 81. The square above 98 is 100. 98 is closer to 100, therefore if we plug this in the calculator, we should expect the square root of 98 to be closer to 10 than 9. And sure enough, the square root of 98 is 9.9. In letter B here, we have a negative of square root of 39. Now once again, we want to apply our we'll we'll figure out the square root of 39 and then just apply the negative to it. So we look at 39. The closest square to the left of 39 on the number line is 36, which is 6. The square above 39 is 49, which is 7 squared. And 39 is closer to 36 than it is to 49. So that means that our square here should be something closer to 36 than 49, and it sure is. It's a negative 6.24. So that does put it closer to 6 than 7. And this last one here, square root of 55. The square below it is what? 49, of course. The square above it is 64. 55 is right about in the middle, so this one should be close to halfway between 49 and 64, which means it's going to be 7 point something. And when we run it through the calculator, we get 7.42. All right, open the last flap. Let's go through some simple examples using square roots. In this first one, we have 5 times the square root of 225 minus 10. Now, we haven't done order of operations yet. We're going to work on that one in Unit 2. But we do know we have to take that square root first. So when we take that square root, we have 5 times 15 minus 10. 15 minus 10, of course, is 5. So we have 5 times 5, or 25. Down here in B, we have negative 125 plus 3 times the square root of 400. The square root of 400 is 20, so we can calculate this as negative 125 plus 3 times 20, which equals negative 125 plus 60. And using the integer facts that we use, we take that and we end up with negative 65. Now, in C and D, things get even trickier. When we have squares inside a square root, we can separate these into the square root of 64 divided by the square root of 4. Okay? And so when we can take 64 and divide it by 4, which is probably a little easier. So let's take 64 divided by 4. That's 16. So this turns out to be square root of 16, times the square root of 9. Well, the square root of 16 is 4. The square root of 9 is 3. 4 times 3, of course, is 12. Pretty straightforward. Now, last one down here, we have square root of 25 divided by the square root of 16. 25 and 16 we can't divide out. But what we can do is we can take the square root of 25 and rewrite it as the square root of 25 over the square root of 16 plus 3/4. Okay. Then we know the square root of 25 is 5. The square root of 16 is 4. So that becomes 5 over 4 plus 3 over 4. And we know that with fractions, if the denominators, the bottom number, is the same, we can just add the tops. So 5 plus 3 is 8 divided by 4. 8 divided by 4 is 2. All right, so today we've learned how to work with some square roots. And we'll now get started on we'll do some classwork to practice these skills. And then we'll be back tomorrow for a lesson on the percent proportion. So have a good evening, and I will see you in class.